So welcome to Next Gen Dev. In this video, we will be creating a backend application using Node.js and TypeScript. Node.js is one of the most popular framework out there, and with the help of a TypeScript, we can make our web application more robust. In this video, we are following all the modern practices that are used for creating a backend application, such as sending an OTP to the user for validation, or creating complex relationship between different models of our database, or using Helmet for making our HTTP request more secure. We are following all the modern practices. The database that we are using in this video is PostgreSQL, which we are fetching from a Docker container. As you can see here, we are using Postman for our API testing, and we are using Prisma for our all database interaction and schema creation, as you can see here. So at the end of this video, you will be able to learn all the modern practices that are needed to create a professional level backend application. So let's get started. So right now I'm in a new empty folder, and before starting this project, what you need to do is you need to install Node.js in your system and also Docker in your system. Both the links will be provided in the description. After successful installation, what you would do is you would write code --version, and you will see a number printed out. If there is an error, that means the Node.js hasn't been installed in your system, so reinstall it. After that, what you have to do is you have to initialize your Node.js app. So to do that, what you have to do is you have to write npm init. It will start initializing. What I would like to add is -y. What it would do is it would skip all the questions for me. So as you can see, your package.json has been created. It has the name, which is Docker. It has a version. It has a description, which you can provide by yourself. What I would like to add here is I would like to add here a few scripts. One is the start script. In the start script, it would say node, and the name of the file would be index.js, which I will create later. And the dev script would be for the local development. It would be node on, and it would be index.ts. All right, so for that, we need to install Nodebon as well. So let us install that, npmi Nodebon. Nodebon will basically update our server whenever a change is made. So we don't need to restart our server manually. All right, so we have Nodebon as well. As you can see, a node module file has been created by the installation. And after that, what we have to do is wait. And after that, what we have to do is we have to install some packages. So as we are developing it in TypeScript, so we need TypeScript, npmi TypeScript, and we need Node for TypeScript. So ts-node. This is Node.js for TypeScript. So let's install that. All right, so after the successful installation of TypeScript, what we have to do is we have to install the types for our Node.js and Express as well. So before that, let me install Express. Express is our server that would carry our data. And after the installation of Express, what we would do is we would install types for Node.js and types for Express, as we are using TypeScript. So we need types for these files. And whenever you're installing type, you can install it as a dev dependency, which means that these files won't be used when you are in a production mode. So it would be only used when you are locally developing it. So as you can see, it has been installed as a dev dependency. So all right, let us create our server. So for that, I will create an index.ts file. So in this file, first I would import Express. Wait, Express from Express. After importing Express, what I would do is I would create a file called app. That's my Express in it. With the help of this app, what I would do is I would listen to a code, and it requires a port. So let me create a port variable as well. Let it be 3000 for now. And it will be port, and then our callback function, and this function will just print the message server started. And what we could do is we could create a route to check whether our app is working or not. So let us create a get route, and the callback function will take request and response. It takes two parameters, and the third is the next, which calls the next function. Request contains all the body of the request that we're sending to the server, and the response contains the output for that request. So let us send some output to our browser. What we could do is we could write test here, and that's it. What we could do now is we could start our server. So as you have seen that we have created a script called dev, so we can use that script instead of writing nodemon. So let us do that, npm run. And now you have to, if you want to use any script, first you need to write npm run and then the name of the script. So it's dev. So it will start my server. Okay, nodemon is not recognized. Wait, I haven't installed it or what? Let me reinstall it. So now it's here. Let's start the server again. And my server has started. As you can see, you have this console out here. So let me open my browser. And in this, I would write localhost 3000. As you can see, you have a test message here. If you want to change something in it, so let me do test one. As you can see, it automatically updates your server. And if you go to your browser, you just need to refresh it. As you can see, you have test one here. So you have successfully installed your Node.js, or you have started your Node.js server. So after setting up your Node.js server, what we need to do is we need to set up our database also. So in order to set up our database, we need to open Docker desktop in a system. So just click on your Docker desktop icon, screen will pop up, and just minimize the screen. Don't need to do anything in there. And after that, what you need to do is you need to create few files. So the first file would be .env file to store our environment variables, and the second would be .gitignore file to ignore our sensitive file from being committed to the GitHub. So in this, I would like to add .env and node modules. All right, then just close your server for now. So after that, what we need to do is we need to install our database in our system. So for that, I'm using Prisma. So let us install that. So npm install Prisma to start the installation of Prisma. And after the installation, what you need to do is you need to initialize your Prisma. So for that, you need to write npx Prisma init to start the process. And as you can see, you have a Prisma folder created. And also in your env file, what you will notice is you have a database URL, which is a PostgreSQL URL. It uses it by default. And the rest of the thing you can remove. You don't need them. And as you can see, it has a username John Doe and a random password. So we need to provide our own username and password. So for that, let's create few fields here. Postgres, and first would be the user. You can write anything you want. I would like to write next gen, and you have to provide a password as well. So just take care of the spellings here. If anything goes wrong, then it won't work. It would be again next gen 1 2 3 4. Anything you can add, it's up to you. And the name of your database. So it would be MyDB. So after doing this, what you have to do is you need to change few fields here. You need to write your username here. So it's next gen in my case, and the password is next gen 1 2 3 4. All right then, and as you can see here, your database is hosted at localhost 5432. But at our localhost, we don't have this database hosted yet. So for that, we need to create a Docker file. And before that, let's look into our Prisma schema as well. It has a client, Prisma client, and the database is Postgres. Okay, then, so let's create a folder here. Name it a Docker folder. And inside this, you need to create a file, compose file, which will create a container and run it on your Docker. So in this file, you need to specify a few things. First is the services that we want to use. So the services that we want to use is the database service. So we can write DB here. And in this, we need to specify the image we want to use. So image is Postgres. Again, just take care of the spellings. If you write wrong, it won't work. And what I would like to add is a restart property to always. So whenever I start my Docker, the database should restart itself. And what else I could give is the environment file. Where is my env file located? I could provide the location of it. So it's one folder behind .env. And then what I could provide is the port on which I want to host my database. So as you have seen in your env file, it's on 5432. So I would like to map my 5432 to the 5432 port of the database. This is called port mapping. And as you can see, we have created our Docker compose file here. And now it's time to start this file. So in order to run this file, what you have to do is you have to go to this directory. So let's go to the Docker first. And then in this file, what you have to do is you have to compose this file. So Docker compose up, press enter, and your database will be started. Just give it a few seconds. So as you can see, your database system is ready to accept connections. And in your Docker as well, if you see, you have a container running here. So you have successfully installed and started your database using Docker. So after setting up the database, what we need to do is we need to create a schema for your database. So in order to do that, what we need to do is we need to go to our Prisma file. And in this file, we need to start creating our models for our database. We close this. So the first model would be the user model. and it's an object, and every model will have an ID. It would be unique. First, you need to specify the type string, and it's unique. And what we could do is we could provide a default value to it that every time a field is created, just run this function UUID. It would generate a random unique ID for your entry. And then what you could do is you could provide an email of type string. Again, this would be unique field. Then what we need to do is we need to provide the first name of type string and last name type string. The last name would be optional because it's not mandatory that every user will have a last name. And what we could do is we could specify the size for these fields. So for that, you could use database dot varchar. Okay, it would be a small letter, not capital. And in this, you could provide the maximum size that you want to have here. Okay, again, it is in camel case. And the same thing you could do for the last name dot varchar. So the maximum size for entry of these fields have 50 characters only. Then you could provide a username as well of type string. And again, each user will have a unique username. After that, what you could do is you could provide a profile image type string and yeah, and also a cover image type string as well. Again, these two fields can be optional because it is not mandatory that a user will have a profile image and a cover image as well. Or you could provide a default image by the first name of the letter that you could do easily. You don't need to specify any field here. So after that, you could also provide a bio, just a description about the user or anything. Just and it would also be an optional field because it is not mandatory to have a bio. Then what you could do is you could check whether a user is verified or not. So whether the user email is verified or not. So email verified, and you could write a date time here. It basically will specify at which point of time this email has been verified. So and also you could provide a password field here, and we won't store password directly, so we need to provide a hashed password field, hashed password, and it would be a string. And you could do this optional because if you are using some auth provider such as Google or Facebook, then that user won't have a password. But if you are using normal credentials, then user will have a password. So yeah, and also email verified at the beginning it would be undefined, so it is optional. And after entering an OTP, then it would be verified. So the date time would be an optional field here. Then what you could do is you could provide a has notification here. What this would signify is whether this user has any new notification or not. So you could render an icon in the front end of the application, which will imply that a user has a new notification. Again, and the default would be, again, you could provide it a Boolean, and the default would be false. Initially, it won't have any notification. After some time, it might have. So, and then what you could do is, yeah, whether it is a pro member or a paid member of this application or not. So you could also check that is member Boolean, and at default, you could do a false here. And then what you could do is you could add few fields such as created at and updated at. So let's do that as well. And the created at would be date time, and by default it would be now. Whenever this field is created, just add that value. And updated at would be again date time, and it would be at updated at. So this is the basic model. And again, after creating other models, we will add relationship also in these models. So for that, we need to create other models first. Okay, then the second model that I want to create is a post model. So let's do that. So in this model, again, it would have an ID type string, and it would be unique, and default would be UUID. Again, and each post will have a body in which the content would be there, would be of type string, and it would be required because we need a post because a post cannot have an empty body. So again, after that, what we could do is we could specify the user that has posted this. So user ID type string again, and we need to specify the relationship with our user model because a single user will have a multiple post, and each post will have a single user. So it's one to many relationship in case of post. Sorry, in case of user, and for post is one to one relationship. And so for that, what you need to do is you need to create a user field, and the type would be of user. Then you need to specify the relationship. So it would be the referencing field would be the ID of the user. So in reference, we need to provide which field from the user table that you want to map. So we need to provide the user ID here. And in the post field, we need to provide the which field you are mapping to. So in this, we have a user ID here. So user ID, and then you could provide is on delete cascade, which means that if a user is deleted, then the all post related to it should also be deleted. So just save this file. And as you can see, you have a post entry here, which has array of post. So I would like to change this name to small caps. And this is how you could create a relationship in schema Prisma. So after that, what we need to do is we need to create a different fields such as comments, such as notifications, and then we need to create a relationship between them. So let me first create different fields. Then I would like to create notifications here. So the third model that I would like to create is comment, and each comment will have an ID as well. And also you could provide created at and updated at to the post as well. Okay. So now we have a comment. So each comment will have an ID of type string. It would be unique field and default would be again UUID. Then each comment will have again have a body here, type string. Each comment will have a user and a post as well. So first I need to map a user, then the relationship with the user. So the referencing field would be the ID of the user, and the field of this comment would be user ID. And again, on delete cascade, delete all the comments, and the user is deleted. And save this. As you can see, you have a comment field here as well. So you could also, and each comment will be associated to a post. So let us do that as well. Post ID, and each post ID will be of type string, and it would be of type post. The relationship would be the ID of the post. The fields would be the post ID, and the same delete all the comments if a post is deleted. Again, it's up to your business need. If you want to keep the comments for your privacy and security, then you could do that. Otherwise, you could remove them. So this is how you create different relationship in your schema. And after that, what you could do is, so each comment will be related to a post, or it would be a reply to that particular comment. So there would be relationships such as a comment to a comment. So it would be a self relationship. So we need to specify that as well. So there would be use case where a comment is for a comment, not for a post. So what we need to do is we need to specify that this post ID would be an optional field, because each comment will either belong to a post or a comment. We need to do that, and also here we need to specify it is an optional field. So the third thing which I would like to add is whenever a comment is made for a different comment. So let's do that as well. So it will be comment ID. And this comment would be the parent comment on which this comment has been made. So parent comment ID, and it would be of type string. Again, it would be an optional because either it would be a reply to a comment or a comment to a post. So then let's create a field type comment. Again, it would be an optional field, and we need to specify the relationship here. So the relationship would be the reply to a particular comment, because we could also provide a name here like reply reply to comment. And again, the references would be the ID of the field which you want to do, and the fields would be parent comment ID. And on delete, it would be cascade. And then you could create a comment replies. It would be of type comment, and you need to specify the relationship here. So it's this relationship which we are talking about. And then what we could do is we could save this one. So as you can see, no error is here. So let me just give you a recap of what happened here. So we created a comment field, and each comment will have an ID, content of that comment. Then each comment will be associated to a user, and either a comment will be associated to the post or to a reply of a particular comment. So when it is associated to a post, this relationship would hold, and when a comment is associated to a different comment, then this relationship will hold. I'm using I'm also using providing a name to this comment relationship. The first parameter you could provide to any relationship is the name. Then you could provide the reference, the field that you want to map, and the field of this particular model which you want to map with. So I have done that, and here I have created a comment reply field and specify the name of that relationship. So after creating the comment model, what we could do is we could create another model that would basically map the relationship of a user to another user. What I mean by that is, as you have seen in social media apps such as Twitter and Instagram, you can follow a user and that user can follow you as well. So I need to map that relationship here. So for that, what I would do is I would create a new model. It would be user follows. And in this model, basically, I will map a particular user to another user. So to do that, first I need the ID of the user that this user is followed by. And again, the type would be string. And again, I need to specify the relationship of it. So followed, let me write the ID. So followed by, it would be of type user, and the relationship would be, See, as it would have two relationship. One is the following relationship, and second is the followed by relationship. So when you have two similar type of relationship, the better practice is to name those relationship. So I'm going to do that as well. So followed by would be, and the references would be the user ID of the field, and from this field I would use followed by ID. Okay, so after that, what you could do is you could map the relationship of the user which this user is following. Following ID, it would be of type string, and then again you could create a relationship, and it would be of type again a user, and the relationship would be following. The references would be the user ID of that field, this ID here, and the from this field what I would take is, wait, okay. So following ID. Okay, so now we have created a relationship in which a user will follow another user, and this user will be followed by some other user, as we have seen on Instagram and Twitter as well. So after creating this model, as you can see, this model does not have any unique key or unique field in order to iterate it or find it. So we need to specify that these IDs are basically the unique keys in this model. So to do that, you have to create an ID field, and in this you have to provide your followed. Okay, this would be an array. When you are providing a multiple keys, then you need to give pass in array, and then the second would be following ID. Okay, so now you need to create these relationship in the user model. So let us do that as well. I mean, I would like to separate my relationship and the normal entries. Okay, so first would be followed by, it would be user follows, and what relationship of you, as user follows has two different relationships, so we need to specify the relationship which we want to use. So it would be followed by, again, I did a typo here as well. Okay, then the second relationship would be following. Again, user follows, the relationship would be following. See, so using this, you have mapped the user with the following and followed by relationship. So after creating the following relationship, what I would like to do is to add a like a post or like a comment functionality. So for that, I have to create another model, and it would be like post. And in this, we will have a post ID of type string, because whenever you like a post, it would be associated to a string, to a post, sorry. Then we will have a relationship of post, and again a relationship. In this relationship, what you would do is you would name it like post like, just to differentiate it with the name, and the references would be the post ID, the this ID, and the field from this model would be the post ID here. And again, you could also provide on delete cascade, which means if a post is deleted, then all these things would be, but you don't need, because you're not storing anything here, you're just specifying a relationship here. Okay, so the next thing would be whenever you like some post, a user likes a post. So basically, it would be such a relationship where like is associated with a user, and that like is associated with a post. So we have associated a post here. So now we have to associate a user with it also. The user ID, type string, and then the relationship. This would be user like, and the references would be the user ID, and the fields would be user ID from this field or this model. And so after that, what we have to do is, again, we have to specify what would be the key in order to iterate this, or the ID field. So again, we could give it post ID, and we could give user ID. Why we have to do this? Because whenever we'll run our queries in our database in order to search for the liked post. So if we provide a key value, so that our query will be more optimized and it would take less time in order to produce result. And also each and every model should have at least one unique key. So you need to specify that. And now in our post model, I will define the like relationship. So it would be post likes, and it would be of type like post, and it would have a relationship. The name would be post like. Okay, so the next thing which we have to do is we have to add this on the user field as well. So it would be liked post. It would be, the name would be again like post. The relationship would be what we have named here, user like, and it would be an array as well, because from a single post will be liked by multiple user, and a single user will like multiple posts. So that's why we need to make it as array. Okay, so what else we could do here is we could give the same functionality for our comments also, because as you can see, whenever you comment on your post, so other users can also like and reply to your post. So we have given the reply relationship here. Now it's time to give the like relationship. So like comment. Again, it would be related with two attributes. The first would be the user ID, and the second would be the comment ID. So let's get started in that. So comment ID would be of type string, and again, the relationship would be comment type comment, and the relationship again you could give it a name like comment like, and the references would be the ID of the comment, and the fields would be comment ID. And the second thing would be the user ID. The user like this comment would be of type string again. The relationship type user would be user likes, or yeah, user like would be, now you already use that now. So user comment like, and the references would be again the ID, and the fields would be user ID. And again, you need to specify an ID field here. It would be your comment ID, and the second would be the user ID. After that, you have to specify these relationships. So yeah, it would be like or comment likes or just likes, Maybe let me follow a standard practice. I've used it post likes here, so I should use comment likes here. Type like comment, and again, it would be an array because multiple users will like it, and the relationship would be comment like this one. And the other thing would be same thing. I have to do it in the user field as well. You liked comment, like comment again, multiple posts you can like, or a tweet or a comment you can like, and the name is user comment like. Just need to copy and paste it here. That's it. No errors as of now. So now you have created a relationship in order to like a post and in order to like a comment. So now let us create our notification model. So model notification. Again, this model will have a same thing such as ID of type string, would be unique, and the default would be UUID, and other fields such as the message. This would be of type string, and what else we could have is which user is receiving this notification. So for that we have user ID type string, and then what we could do is we could specify a relationship, so user of type user, and the relationship would name this relationship because we will have multiple user relationship in this notification. So it would be user received, the user which has received this notification, and the references would be the ID, and the fields would be user ID. Again, you can also specify on delete cascade, like if a user is deleted, delete all its notification. But if you want to keep those notification, it's up to you again. So after doing this, we need to specify this also in our user model. So it would be notifications. We do it here. Notifications type notification. It will be an array because a user will have a multiple notification. And what name did I give? It was user received. So just paste it here. With the second thing which we could add in our notification field is the type of the notification. And so if the type of notification means that it would be of a post, or it could be of user, or it could be the system notification, it could be anything. So the major criteria for the notification would be the whenever a user likes a post or comments on a post, so that would all go to a post criteria. And if a user is following other user, or yeah, it just follows other user, then it would be of type following user. So in order to add types in our models, what we could do is we could create an enum notification types. And what we could do is we could create different types. For first would be the user type, second would be the post type, third would be the comment type, like someone commented on a post. And then fourth would be system. System will be basically an update. The app has been updated or the privacy policies has been updated. If you want to push that type of notification, then you can use system type. And then what we could do is we could use these types in our notification model. Let me show you how to do that. So first create a field called type, and it would be of notification types. That's it. So only these values are permissible whenever we are storing our notification in our database. Then what else we could do is we could create a reference relationship. What I mean by that is whenever a user receives a notification, it could be like a user has liked your post or a user has commented on your post. So basically in these type of things, what you could do is you could provide which user has liked a post or which post has been liked. So you could also provide that reference as well. So in order to do that, what you could do is first you could create a ref user field, ref user ID of type string, and again you could create a relationship for that. Relation. Okay, so relation. I need to specify the type first, and the relation would be the sent user, which user sent you this notification or because of which user this notification has been generated. References will be again an ID. Fields would be the ref user ID. And in this, you don't need to provide on delete cascade. Then we could also provide ref post ID type string, and again the relationship for it would be of type post, and a relation it would be sent post, and the references would be again the ID of the post, and the fields would be post ID, ref post ID. So, and the third would be the comment, because if a user replies on a comment, then the notification would be XYZ person has replied on your comment. So ref comment ID type string, then ref comment as well of type comment, and the relationship would be sent comment. References would be ID, fields would be ref comment ID. Again, what I want to specify here is that these fields are optional, because there would be a case if there is a system notification. So that notification won't have any user, won't have any post, or won't have any comment. Or if a user likes a post, then it won't have a comment. So these fields should be optional here. So before that, you need to just add question marks just after the type, and here as well. All right, so now you need to specify these relationship in the user model, post model, and comment model. So let's do that as well. So it would be first the notification one, which we have specified, ref notification would be again of type notification, and the relationship would be sent to user. Then the same thing I have to do it in our post model as well. It would be ref post, or just ref notification, I would say. And it would be again of type notifications, and the relationship would be sent post. The same thing I have to do it in the comment as well. It would be ref notification of type notification, and then a relationship sent comment. See, all the errors have gone. So basically, whenever a notification will be generated, we also have an optional field in order to pass the user that has sent that notification, or the post on which that notification has generated. So whenever when we display this message on our front end application, we could specify this post has been liked and this is the comment. All these things we can specify. And the message we could say this post has been liked, and the type basically which type of notification we are expecting. So if the type is user, then we know that it will have ref user ID and all. So it would be easy for us to validate in our front end application. So moving on to our last model, this is OTP model. So this model again will have an ID type string, and it would be again unique, and at default would be UUID. And what else we could give, body again, or the value whatever you would like, type string. You could make it a number also, but if you are using string, then it would give you more flexibility. Then what you could do is you could yeah, you could relate it to the user which has received this notification or this OTP, type string, and the user of type user, and at relationship, the references would be the ID of the user, and the field would be user ID. And again, on delete cascade, because we don't want to keep these OTPs and the user is no longer in our database. Then the second thing what we could do is we could specify a field whether this OTP has been used or not. So is used, it would be of type Boolean, and again by default it would be false. That means this OTP hasn't been used yet. And what else? Yeah, expiration date. This will basically specify till when this OTP is valid. So, and the default would be, you don't need to specify default here. Yeah, it would be whatever time this field has been created plus 10 minutes or 5 minutes or whatever you want to specify, and then would be created at, and it would be date time. Default would be now, and updated at as well would be of type date time, and the default would be, sorry, not default, it would be date updated at, sorry. And also you need to specify the relationship here as well in your user model. As you can see, an OTP has been generated. I would like to do it in small caps, so OTPs. All right, so with that said, your user model is finally been created. I guess I have missed created at and updated at in few models. So let me just quickly add that. Okay, here it is. Here we don't need. You can specify when the user has liked your comment. And then in comments also we need this field. Then when the user has liked this post, need that as well. When a post is created, basically you need this at every. Okay, I've already specified it. My bad. And when the user has started following you, And in this, I have already specified here. So yeah, with that said, you have completed your schema of this Node.js application. I know it was a bit complex. It has all sorts of relationship, whether it was one-to-one, one-to-many relationship, or self relationships. It was everything was there. You created enums in order to provide types to your notifications. You created a model for your OTP as well. So you did all sorts of complex relationship that is needed in order to build a professional Node.js application. I hope you like this schema video. And in the next part, we'll start developing our APIs.